What's up, guys, and welcome to Math with McKay. All right, so today we are focusing on decomposing fractions. And to decompose a fraction is just simply to break apart a fraction or a mixed number into smaller pieces, right? So what I would do to start this off is I would give my students this, right? There's nothing on it but just a long rectangle, right? And then they would have to come up with some ideas on what this could possibly represent, right? Could this be the whole? Could this be part of it? Just have them kind of like discuss what this is, right? Even if it has numbers on it or not, preferably, without numbers. Mine does have a number on it, but I would give it to them, with nothing on it, just the blank side, right? So then from there, I would give them some other pieces and kind of ask, well, how many of these pieces, which is also, nothing on one side, and then you have the portion on the other side. How many of these pieces do they think could make up this one whole, right? So then as they're working together in groups, they can go ahead and begin to play with the idea or, just figure out how many halves make up a whole, just so that they can get the concept of how much one whole is equivalent to. And then you can give them some smaller pieces like these yellow ones, right? So then I would go ahead and have them compare to see how many of these yellow ones could I put together to make this whole, just so they can understand that this whole can represent any fraction that we want it to represent. We just need to go ahead and make sure that we're breaking it down accordingly, right? So for example, if we wanted to represent 5, 6, right? I would go ahead and take this rectangle, which would be similar to this as what they would have in their hands, and go ahead and split it into 6 pieces, because our denominator tells us how much we have all together, and our numerator tells us how many of what we have is actually utilized, shaded in, or, things along those lines. So I'm going to go ahead and split this into 6 pieces, draw 5 lines on. So now I have my 6 pieces, which my denominator tells me how many pieces I have. So I have 1, 2, 3, 4, 5, 6, right? And then of those 6, I only want to shade in 5. 1, 2, 3, 4, 5. Okay? So again, showing students that this represents one whole, right? And of the one whole, we have 5, 6. Now, we want to decompose 5, 6. Now, there's many ways that we can do this. So we'll go ahead and I'll go ahead and draw another number bond on the side, just so we can see that this can be done multiple ways, right? So one way is I can take 2 of these and then 3 of these to make 5, 6. So this would represent 2, 6, and then this would represent 3, 6. So then I put them over here in my number bond, and I say that 2, 6 plus 3, 6 is equal to 5, 6, right? That's one way we can do it. Or I can use another set of numbers. Instead of it being 2 and 3, I can break it down into even smaller pieces. And I can say these 2, this 1, and then these 2. So this right here is representing 2, 6. This is representing 1, 6. And then this is representing 2, 6. So 2, 6 plus 1, 6 plus 2, 6 is equal to 5, 6. So really, when we are decomposing, we're just figuring out all of the different combinations that we could use to create this specific number that we're working with. And in our case, it was 5, 6. Okay? All right, so now let's try with a mixed number, right? So say, for example, we had 1 3/4, right? So the denominator tells us how many sections we should have in each one of our rectangles. So in this case, based on our denominator, we're going to break these two rectangles up into 4 sections, okay? 3 lines will give us 4 sections. I'm not only going to just do this one, I'm going to also do this one because this is one whole and then we have 3/4. So this whole rectangle, again, represents one whole, and this whole rectangle represents one whole. So now we have 2 wholes, but we may or may not need to use the entire thing, right? So let's break this one up into 4 sections, right? So now on this one, because we have one whole, now this one whole can be written as a fraction, which would be, I would shade in 1, 2, 3, 4. So we could take 1 3/4 and say that it is equal to 4/4 plus 3/4. And then you could do 4/4 plus 3/4. Because the numerators are different, the denominators are the same, and we're adding, we can go ahead and just add these regularly. So this is equal to 7/4. And you may not understand how we might have gotten 7/4, right? But once I go ahead and I shade in this 1, 2, 3, then I can go ahead and count that there are 1, 2, 3, 4, 5, 6, 7 boxes shaded completely in, which tells us how we got this 7/4. Now we're going to go ahead over here and decompose 1 3/4 using only 2 numbers. Then we can decompose 1 3/4 using 3 numbers. And then we could also do it 1 3/4 using 4 different ways. Okay? So the first one, we can go ahead and say that it is 4/4 plus 3/4. And how I got that was all 4 of these plus all 3 of these. Okay? That's one way. Another way would be using 3 numbers, right? So let's go there, there, and there. So here, because I only put this bracket or brace around 2, this is representing 2/4. This is also representing 2/4. And then we still have our 3/4. So then we go over here and we say 2/4 plus 2/4 plus 3/4 equals 1 3/4. All right. Now let's try with 4 numbers. All right. We can still do 2/4, 2/4, 2/4, and then 1/4. So we can say 2/4, 2/4, 2/4, and 1/4. And then we just put it in here. 2/4 plus 2/4 plus 2/4 plus 1/4. So when you're decomposing, any way that you can think about breaking the number up, that is decomposing fractions. We are taking the fractional portion that we have, which in our case was 1 3/4, and we're separating it into smaller pieces so that we know that if I take these and I add them together, they are all going to equal what we started with originally. But notice that they all have the same denominators. The denominator is the only thing that does not change when we are decomposing. Your numerator can change. You see how we started off with 3/4 and then we had 2/4 in there. We started off with 4/4 here, and then we broke it up and we were able to get 2/4, 2/4, 2/4, 1/4. Your denominator stays the same because your denominator is representing how many one whole is broken up into, how many pieces the one whole is separated into. So if your one whole was separated into 7 pieces, then 7 would remain your denominator. Thank you guys. I hope that helps.